Okay. Alrighty, hey everybody. I'm Brett, Creative Director of False Prophet Labs. We're a local organization. We're dedicated to producing art that's science-based, which basically means that we take our inspiration from scientific principles and we turn it into art projects. We're going to demonstrate a couple of projects here today that are coming out of our labs. There are two projects that we hope to show at Maker Faire, and both of them involve fire, and both of them involve fire on a personal level. In other words, fire that's interactive, fire that is small but that you can touch and feel and be a part of in an interactive way. So I'm going to hand it over to Kurt now. He's going to talk about the first project, which is called Pyrocardium.
Hi everybody, I'm Kurt Thorne, and sort of what you see here on the left side of the table, your right side, is the very much in progress piece called Pyrocardium. The final goal of this is to build a largish sculpture, probably sort of 10 feet tall, which is going to have a whole bunch of sound-activated flame effects on it, with the eventual thought that we'll have it hooked up to a stethoscope with a microphone on it, and you'll be able to sit in front of this. Currently we're planning a double helix of flames, and that it'll pulse in time to your heartbeat, so these flames will shoot up around the edges of this double helix as your heart beats. As you can see, we're still a ways away from that, but I think hopefully you'll see today we've got most of the technical kinks worked out, and we hope to start the sculpture design in the next week or so. So basically the way this works is we have a microphone here. It's hooked up to a computer, which is sitting in the crate there. It's running some custom written software, which you can sort of see here. That's this guy. And by talking to the mic here, you'll hear that clicking. That's relays firing. I'll go over how the whole setup is in a second. But you'll also see these red dots light up here. So test, test. And so that's the software which is recording the input from this microphone and then basically measuring the volume of the sound and then choosing how many channels to turn on. So this is set up to do 20 channels, basically 10 left, 10 right. And the idea is we'll have 10 of these flame tubes, which are these guys running up the edges of this helix, and as the sound gets louder or as your heart beats, more will ignite until these flames will race up and down the edges of this helix. So the way this all works is the computer here obviously takes input from the microphone, it does the digitization and volume measuring, and then it sends signals to this little blue box here. This is an off-the-shelf USB to digital I/O board. It has 24 I/O channels, and those go into this custom-built circuitry here, which is just a bunch of relay controllers. So we'll eventually have 2 of these. Each of them can drive 10 channels, and this basically just serves to take the low-level 0 to 5 volt logic signals from the digital I/O card and translate those into high-power switching, which can control these solenoids back here. So these are
these solenoids are what we're hearing, right?
Yeah, well, you're actually hearing clicking of these relays on the board and clicking of the solenoids. So the solenoids basically take a 0 to 24 volt signal and open and close, and they're just digitally controlled valves. So when they're open, gas flows. When they're closed, no gas flows. Right now, they're all sort of jammed together here just for testing purposes. Eventually, they're going to be split up, and they will be directly attached to these flames. So when the solenoid opens, gas comes out, and you get fire. Fire ignition then is handled by these wires that are dangling here above the tubes, and these are just nichrome wire elements, same stuff that's in your toaster, and they're hooked up here to just a commercial dimmer switch. So if I turn this up, you'll see they will glow, and that's hot enough to ignite the propane jets here. So that's the setup, and so if I turn on the propane tank, then we should get some fire. Yeah. Test. Test, test. 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 So the software still needs a little development, so it's a little hard to go from getting a...
So how's it splitting? Like what's it, in your voice?
It's just volume.
Volume?
So it's just, right now we're running sort of the simplest thing where we just digitally sample the sound and then just take, every 4,000 samples or so, every 1/10 of a second, you just average that and see how loud it is, and then translate that to an, digital I/O, so that, no volume is 0 on, a little bit is 1, 2, 3, 4, 5. It's not perfect. We basically need to do some work on that to make it a lot more elegant and visually appealing. And I think eventually what we're going to do is write a custom algorithm for the stethoscope interface that knows sort of what heartbeats look like and is custom written to give a very aesthetically appealing flame progression as your heart beats. Obviously there's a lot of things, now you have this framework, you can imagine hooking it up to music and writing beat detection algorithms, and so you can have this thing running off of music and sort of pulses in time to beat. You could make a sort of graphic equalizer display where you have a frequency dependent display. You can do all sorts of stuff. So it effectively just becomes another display technology. And that's the sort of idea here.
Okay. Great.
Questions?
How big are the